Domain and Range Part 2. In this video, you'll learn that when given a description of a function in a situation, how to determine a reasonable domain and range for the function. So let's go over domain and range again. We know that the domain is a set of all possible inputs of a function, or the x values. And the range is a set of all possible outputs of a function, or the y values. So if we have a graph like this containing 5 separate points, we can find the domain and range by looking at all of the x values and all of the y values in these 5 points. Let's start by labeling them. First we have -3, -4. The next point is at -2, 5. And then we have 1, 3, 1, -2, and 4, 0. So let's list all these points so we can find the domain and range. The domain is the set of all of the x values. So in this example, the domain will be -2, -3, 1, and 4. There is another 1, but we only need to put it once in our set. Now let's look at the range. So this is the set of all y values. So in this example, our range is 5, -4, 3, 0, and -2. If we have a graph like this one, where they're not separate points, but points that are connected, we could still find the domain and range by looking at the x and y values that are included. So let's start by looking at the domain with the x values. The smallest x value that our function reaches is -4. The open circle on -4 tells us that the function does not equal -4, it just gets very close to it, so that's an endpoint. The largest x value we see actually goes on forever because of the arrow that we see on the other end. So our domain for this function are all x values that are greater than -4. Now let's look at the range. So we'll look at all of the y values that are contained in this function. The smallest y value we see is 1, and that arrow tells us that it will go up forever. So the range will be all values that are greater or equal to 1. Finally, let's look at this graph that is just one straight line that continues forever with both directions. So the domain is all x values, and the arrows let us know that it will continue to go on forever left and right. So the domain will be all x values between -infinity and +infinity. The y values are also going to extend forever up and down. So our range will be all y values between -infinity and +infinity. Now let's look at some examples now that we know a little bit more about domain and range. A child tosses a baseball up into the air. On the way down, it gets caught in a tree for several seconds before falling back down to the ground. We're going to find the domain and range of this function. For the domain, we'll look at all of the x values included in this graph. We can see the smallest x value is 0, and the biggest is 8.5. So our domain will be all values between 0 and 8.5. Now let's look at the y values for the range. The smallest y value the graph touches is 0, and the highest value is a little bit above 12. So our range is all values between 0 and 12.5. Here's another example. To raise funds for a trip, members of a high school math club are holding a game night in a gym. They sell tickets at $5 per person. The gym holds a maximum of 250 people. The amount of money raised is a function of the number of tickets. We're going to find the domain and range of this situation by making a table of guests and profits. If we have 10 guests going to the game night, then we can multiply those by $5 per person, and we would get a profit of $50. If 100 people go, then they will have a profit of $500. The maximum number of guests that fit in the gym are 250, and if we multiply these by $5 per person, they would have a profit of $1,250. So now we can see that our domain would be all positive integers between 0 and 250. We included integers because we can't have a fraction or decimal of a person. Our range is going to be multiples of 5 between 0 and 1,250. Here's another example. The graph of h shows the height in meters of a rocket t seconds after it was launched. Let's look at the y-intercept. This will tell us the height of the rocket before it was launched. We can see that it was at 15, so we can write h of 0 is equal to 15. Now we know that it was 15 meters high before it was launched. Now let's find the domain and range. The domain will look at the x values. and we can see that all values between 0 and 4.6 are included in the domain. Now let's look at the range. The smallest value it hits is 0 when it lands, and the highest height it reaches is around 35. So our range for this function are all y values between 0 and 35. Here's one last example. The graph h represents the height of a bouncing ball over time t. We'll find the domain and range of this function, and we'll start with the domain. We can see that all of the x values included in this function are between 0 and around 3.75. So our domain will be all x values between 0 and 3.75. Now let's look at the range of the function. When we look at our y-axis, the highest point that our ball reached was 6 feet when it was dropped, and the smallest height it reached was 0 when it stopped bouncing. So our range will be all values of y between 0 and 6. Now let's recap what we've learned. The domain of a function is the set of all possible input values. Depending on the situation represented, a function may take all numbers as its input or only a limited set of numbers. And the range of a function is a set of all possible output values. Once we know the domain of a function, we can determine the range that makes sense in the situation.